This topic is interpreting a tree diagram. And a tree diagram is just an organized way at looking at all the possible outcomes of an event. So this first problem says Rita must choose a crust and a topping for her pizza. There are 3 crusts to consider from, or to choose from: thin, regular, and pan. And there's 4 toppings to choose from: sausage, pepperoni, onions, and mushrooms. And then we have all the possible outcomes listed here, and we're going to use this to answer our questions. So if we're looking at a tree diagram, the way we're going to read this is you could pick thin crust and then sausage. So your outcome, one possible outcome is thin crust and sausage. You could also pick thin crust and pepperoni. So there's another possible outcome. You could pick regular crust and onions. So there's another outcome. You could pick pan crust and mushrooms. So there's another outcome, and so on. So when we're looking for how many outcomes, we're just going to count all of these: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We also could have just gone over here and counted 1, 2, the same thing. It would have been 12 over there. So there's 12 outcomes. How many outcomes do not have pan crust being chosen? So any one of our outcomes where pan, all of these ones right here, are out. So we want 1, 2, 3, 4, 5, 6, 7, 8. And how many outcomes have both thin crust and sausage? So we're looking for thin crust and sausage, so that's just this one outcome right there. If it had said either thin crust or sausage, then we'd have to look at this one. This one would work, this one would work, this one would work, and this one would work. Anything that has thin or sausage would work, but this one says both, so there's only one outcome. Here's one more example. It says a class is choosing a president, vice president, and a treasurer. It lists the students running for president, vice president, and treasurer. So we want to know how many outcomes there are. Well, our outcomes are listed right over here, so we could just count all of them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many do not have Jim being chosen? Well, anything that has Jim being chosen, so anything that's connected to Jim, so these outcomes are not going to work. So it looks like that's 1, 2, 3, 4 outcomes. So 12 minus 4 is 8. How many outcomes have both Linda and Jessica being chosen? So we want all of Linda's. So that would be all of these right here. But it has to be Linda and Jessica. So it's only going to work if Linda and Jessica are chosen. So that one and that one and that one. So this one right here, 1, 2, and 3.